background, so apologies if there's any noise. What we're going to be learning today is how to use networks, cross-chain IBC developer toolkits, so that on any IBC enabled chain with a transfer channel between that chain and secret network, you can use secret contracts as confidential data layer in your IBC chain of choice. And today we're going to be learning how to do this on Osmosis mainnet, but you can do this on any chain that has a transfer channel between the design dApps and confidential computing using IBC hooks. And so there's two sections to take note of. We have a key value store tutorial as well as a VRF tutorial, and confidential voting and sealed bid auction tutorials are currently becoming. So let's just go to the basics really quickly so we understand how this works. It's essentially an SDK that abstracts away the complexities of using IBC hooks so that you can use Secret Network as a confidential data layer on your chain of choice. And basically the way that we bridge between Osmosis and Secret, or Atom and Secret, or whatever chain you're using, is with ECDH cryptography. So we have a secure method for generating confidential messages that authenticates users using this ChaCha 1305 algorithm. And you can learn all about the functions, methods, data structures of the SDK here. You understand exactly the types of structs and enums that we're working with. We're not going to do like a technical deep dive right now. I just want to show you how to actually clone the SDK to your machine, and then how to use it to store your first encrypted message, and also how to understand how to do this for a chain of your choice if you don't want to do this with Osmosis mainnet. This goes more into how the TypeScript SDK is structured, and this discusses what IBC hooks are and how to use them. Essentially, if you've never used IBC hooks before, when we do a token transfer between another network and Secret, we can at the same time execute a smart contract. So that's what we're going to be doing today. We're going to initiate a token transfer, and at the same time, we're going to execute a secret contract that we deploy and instantiate, where we're able to store encrypted messages from Osmosis. So let's dive into that tutorial. Before I do that, I'm just going to check if any questions as of yet. Amazing. All right. So I'm currently in the confidential computing layer, IBC developer toolkit section of Secret Docs, and I've gone to the use cases section where we're going to be storing encrypted data on secret networks. And specifically, we're looking at this key value store developer tutorial. So we can see a full stack demo here. This is my wallet that's currently connected. I think that's all right. And we can store a string to encrypt. So this is DoraHacks demo. We're going to encrypt this string. Oops. Okay. And we can see that it was successful. So let's just actually pull this up in our Explorer to see. Open here. Yes. All right. So I'm currently on PingPub, the Explorer of the Cosmos, looking at this osmosis transaction, and we can see that transaction hash on the blockchain. This is where we just stored our encrypted string, and you can see all the information about that, like the transfer channel that we used, the receiver, which is the secret contract, the sender, which is this osmosis address in my Kepler wallet, as well as the transaction response. What we cannot see is the actual data itself, the string that we encrypted. The way the SDK is designed is that only the user who encrypted the data, that wallet address, is able to then query that data. And we're going to learn how to do that now with the SDK. So I just wanted you to kind of see what a full stack demo looks like. And this can be built out with much more complexity. We're actually adding more things like query authentication for the demo, as well as confidential voting and sealed bid auctions, which will be coming to our docs momentarily. But let's go back to doing this ourselves. So we are going to clone the SDK to our machine. And actually, let me just link this in the chat if you want to follow along. All right. All right. So there's two pieces to this today that we're going to be working with. There's the actual TypeScript SDK itself, and then there's the secret contract that we are deploying. It acts as our gateway contract in order to process all of these encrypted messages. So this is the TypeScript SDK. It all lives in this source directory, this source folder, and you can see all sorts of helper functions that allow the SDK to function. So there's things like setting up our client successfully, because we have to have a client that can work with any Cosmos chain, as well as our secret chain. So that's all set up here. We have things like our configuration, things like loading our secret smart contract, loading our IBC configuration, all this sort of stuff. We have functions for uploading contracts, instantiating contracts, for doing all the cryptography that is involved, with like signing messages and encryption. We can see all that here. With actually executing the gateway contract that we're about to upload. And there's IBC TypeScript functions functionality, like sending an IBC token, our hooks memo, right? All this stuff. So don't be overwhelmed by this, or be if you would like, but the good thing to know is that this is all created to abstract the complexities of working with IBC so that you can just focus on what you want to focus on. So let's learn how to actually use this. And before we do that, let's just look at the contract that we're going to be uploading to Secret Network. So that exists here in this contracts folder, source. All that this contract does is it pulls in pieces of the SDK so that we can use that for encryption and decryption. And it just stores strings, user strings, and associates them with a wallet address that stores that string so that we can then query that string in the secret contract. We have this in here. You'll see we have this secrets constant, and all that is the string that is stored and mapped to the address of the wallet that stored the secret, which is just the string. We have two query functions here. We have query with auth data and query with permit. So you can use secret query permits to query the data, or you can use traditional Cosmos auth data queries. And then if we look at our messages for the contract, all that it can do is store a secret, which is a string, like we said, and then query that string. Let's see. And if we look at the contract itself, we will furthermore see exactly that. So these are our two functionalities. We can reset the encryption key and we can store a secret. And I want to see, let's see if we can actually look at this in more detail. Give me 1 second. Let me pull this up. I'm looking for the actual, oh, here we go. So this is where all of the encryption magic actually happens. This is imported from the SDK. It's called handle encrypted wrapper. And if we open this up, this is where all of the encryption magic happens, where everything is abstracted. And this is kind of like where our TypeScript SDK is interfacing with this to do all the encryption magic behind the scenes. So this is like where we have our Cosmos credential, we have our decrypted payload method, we verify the sender, wallet address, their public key, etc., etc. All right. This is not, we're not doing a deep dive of that. I just want you to understand that's kind of everything that's happening underneath the hood. Let us actually deploy this contract now. So I'm going to install the dependencies. So all we've done so far is nothing. We just cloned down the repo to our machine. First thing I'm going to do is install the dependencies. And you'll notice that I just changed this environment variable from .in.test to just .in so that we can actually use the variables in here. This is for Osmosis mainnet. So we see we have two different chain endpoints. We have for secret mainnet and we have for Osmosis mainnet. And then we have all the information for our consumer chain, like the chain ID, the token, the gas price, etc. If you wanted to do this for another chain, all you have to do is just change out these variables to be for your chain. But we're doing this for Osmosis mainnet. So for this demo, I just created a new Kepler wallet and I sent over like $1 worth of secret and Osmosis. So feel free to rug me immediately after this demo is over if you're like, well, these are my seed phrases. Okay. And the other thing I'm going to do real quickly is compile the secret contract. So far, all we've done is cloned the repo down to our machine. We uploaded in file to have our correct mnemonic, and we are now building the contract. We're compiling the contract to upload to the secret network. Any questions yet? Wonderful. Okay, let's go back to the docs. I'm just following these docs line by line so you can do this exact same thing on your own without me. So this just tells us that after you compile the contract, it ends up in this directory. Now the next step is just to compile the TypeScript folders so that we can use them with Node. So we do that with just command npm run build. And all that's doing is just taking the source folder here and then putting them into this dist folder here so that we can then run these commands. And all we're going to be running is this execute gateway.js. Oh, and also deploy. So in here, we can see we have this deploy command. And all that this is doing is just uploading and instantiate that smart contract that we just compiled. So it's already all written out for you. I'm gonna run deploy. And it's gonna return the code ID, the contract hash, and the contract address of our secret smart contract. There we go. And the next step, all that we need to do is, the way the SDK works is it pulls from these config parameters here. I'm just going to upload the contract JSON, point to my correct contract code hash and contract address. And the amazing thing about this tutorial, right, everything we're doing here, you can do this exact same thing and you'll have the SDK working for you out of the box. And you can even customize the secret contract that you upload to do whatever you want. Like if you wanted to make that into a voting contract or a randomness contract, the wrong things. The sky is the limit. This is just teaching you the very basics of how to like actually interface with the SDK, so that you can then create your own secret contract and do whatever you want. All right, that's that. So the next step is to actually encrypt the payload. So we're going to run this command in a second. But before we do, and let's just look at that command really quickly. We're going to run execute gateway. And all that this is doing is storing that encrypted string in our contract. So let's actually change the text that we want to store. We'll just call this DoraHacks demo October 1st, 2024. And then, so this is the string that we're going to store encrypted, and we're going to pass it from osmosis to secret. And then it's just going to add some random characters to the end of that, I guess. You'll see in this function, all that we're doing is just getting our gateway encryption key. So the gateway, this is just the ECDH cryptography that's been abstracted away. We're pulling the encryption key from that contract. We are getting our signing client set up correctly on osmosis. That's all that this is doing using the SDK. And then we're going to sign and execute this message. And we're going to also send an IBC hook. And actually, we're not going to even look at that right now. So let's do that. Let's actually just call this. And while that's executing, let's understand how that encryption function actually works. So yes, at a high level, you can think of the SDK like this. There's a gateway contract that's deployed to secret, which has the ability to encrypt the string as well as query the encrypted string, which is what we just deployed to secret. When we instantiated that gateway contract, we also instantiated it with a public and private key, which is able to be used for encryption. The gateway contract imports helper functions from the SDK, which is where we have the various encryption and query types. All of the encryption logic that's happening is happening in that function I pulled up, that method, handle encrypted wrapper. And what it does is it just first off checks if the message is encrypted, because the SDK is designed where you don't have to pass an encrypted message. You can make it unencrypted if you want, but for our purposes, we're passing an encrypted message. If it's encrypted, it proceeds with the decryption. It extracts the encryption parameters, checks the nonce to prevent replay attacks, loads the encryption wallet storage, and decrypts the payload, verifies credentials, deserializes the inner message, converts this, returns the decrypted message and updated info. Let's see how this is going. And I'm using the Wi-Fi at the mainnet. So this usually happens instantaneously, but we have a lot of people probably on this Wi-Fi. Let me see if I try to run it again, if we have better luck. There we go. So this is our IBC send message. DoraHacks demo October 1st with this extra random string attached to the end of it. This is our transaction hash. We can actually look at that on the Explorer. Oops, the unencrypted method. Let's see. Oh yeah. So this new text here. So we actually called both methods simultaneously. We did the unencrypted string and we did a encrypted. So this new text here, this is what's actually being encrypted. New text. New text is the unencrypted. So we can actually see that here. So that's what was passed in the memo. And then if we look at this transaction, I think this should be the one where it's encrypted. Let's take a look. Okay, great. So now you see the encrypted payload. So that's this right here, right? So now we see it's completely nonsensical. You have no idea what this means. Our payloads have been encrypted. So the demo actually shows how to do an unencrypted as well as an encrypted, just so you can see the difference. That like in the other one, in plain text, you can publicly see the message that you're encrypting or that you're leaving unencrypted. Here we have an authenticated and encrypted message. All right. And so the text, the encrypted text was this here, new text. That's what we actually called here. And then we get back this query response. Or we're able to query it with this query gateway authentication. And the important thing to note about this is just that you can only encrypt the string with the correct wallet address. So if I tried to this, like let's just comment everything else out here so we can see that. So we're going to call, let's see. Query gateway off. I think this should work. Let's try this. Oh, we need a signer. Because it has to authenticate our wallet address. So we have to have that's why we need this, so we can authenticate the signer. So let's try that again. Signing wallet is not defined. I'm just trying to call the query now if the internet will work, just so you can see that you have to have the correct signing wallet in order to actually query the encrypted data. But if this doesn't work right now, it's okay too. Just give it a sec. Does anyone have any questions in the meantime while we wait for this query to be returned? There we go. All right, so you see how we had our encrypted string return? That's because we had the correct wallet address that was the wallet address that signed the message. But now if I try to do that with a different wallet address, so if I updated my environment variables and we said like, now the query should fail automatically. Invalid mnemonic checksum. That is the demo. Thank you everyone for listening. I'm going to check the comments. So we have one person typing, J.U. Greg. I think the main thing to just note is that this is built to be completely transposable, to be able to do anything you want with secret contracts. So like right now, the way that our gateway contract is designed, we create these inner methods here, which is just store secret and get secret. But you can just use this as a boilerplate contract to create any methods you want. And if you want to use the SDK, all that you have to do is just write your new method and have it be inside of inner methods. And then that's how we're able to actually use the gateway SDK here, which is where like all of our types and things are defined for the SDK. So we go into here, this is all, in more detail. But basically, like let's say if you wanted to make like a private voting contract, you would just call like store vote here, right? And then you would just define that functionality in here and then import the SDK here. So J.U. Greg asks, it's about sending a secret message to another chain, but we can also have the secret staying on secret network. Yes. So I'm not sure if I was clear up top, but everything that's happening here, you could do this all on secret if you want. And that's even easier. You don't even need the SDK if you wanted everything just to happen on secret network. The point of the SDK just makes it so that any Cosmos chain that has a transfer channel between that chain and secret network can use this SDK to be able to access secret contracts as a confidential computation layer. And so it just makes it so that like if you're on Osmosis or you're on Neutron or you're on Cash, whatever it is, if you want those users to just feel comfortable using those wallets and using then they're able to just in like with their cache address or with their Osmosis address have access to using secret contracts. Everything it happens inside of a secret contract. It's just that when the token transfer happens from that network to secret, this secret contract, this gate contract that we published on chain is being executed. That's all that's happening. Awesome. All right, everybody. Thank you so much for listening. This has been our confidential computation for IBC demo. I am Seanrad on Discord and on Telegram, and I'm Secret Seanrad on X. So if you have any questions, if you watch this back on YouTube and you want to learn more, you want to dive deeper, if anything is unclear, please DM me, please message me on Telegram or Discord, and I'll be there to assist you. We have more developer workshops next week on Tuesday at noon Eastern time. We're going to have a Solana developer workshop, a cross-chain Solana workshop. So if that's interesting to you, please join that. We want to thank our partner DoraHacks for being such a great hackathon partner. And we very much look forward to seeing what you build. Thank you, everybody.